Okay, in this segment, I'm going to walk through another example of how to choose the correct t-value from the t-table. So if you have the t-probability distribution, the t-table handy, you will want to have access to that, page 388 in SPATS. And here's what I'm asking you to assume. N sub 1 equals 8, N sub 2 equals 8, so 2 samples, 2 groups of scores, same size, 8 folks in each, or 8 things, 8 cases in each sample. N sub 1 equals 8, N sub 2 equals 8. You've been asked to test the hypothesis at the 0.01 level. You've been asked to assume a one-tailed test, but also I added a little bit more detail here. Assume that the hypotheses, and I'm simply using H sub 1 and H sub 0 to indicate the hypotheses, assume the hypotheses say lesser than, all right? So direction has been stated, that's what makes us need a one-tailed test. Direction has been stated, and we also know that the critical region, the tail, the rejection region, that all means the same thing. The critical region, the rejection region, the tail, is going to be in the left-hand side. So let's first talk about picking the correct t-value from the t-table. All right, as before, you need to know your degrees of freedom. This is the same thing you've needed to know for pretty much every single problem you've conducted using the t-table. You need to know your degrees of freedom, and you need to know your task at hand. Degrees of freedom, task at hand. Find out where those two things intersect. These in the middle are t-values. That's the amount of standard error we can expect given certain conditions. So in this case, the degrees of freedom are going to be n sub 1 plus n sub 2. I'm screwing this up, sorry. Degrees of freedom equals n sub 1 plus n sub 2 minus 2, which means degrees of freedom equals 8 plus 8 minus 2, which equals 14. That's degrees of freedom, 14, right? So our t-value is going to come from there, from that row that's labeled 14 degrees of freedom. Our task at hand is a one-tailed test at the 0.01 level. One-tailed test at the 0.01 level. So one-tailed test, 0.01 level, 14 degrees of freedom. One-tailed test, 0.01 level, 14 degrees of freedom. The t-value is 2.624. 2.624. Now, what would that look like on a drawing? Well, let's do it. I'm going to draw the bell-shaped curve, the normal probability distribution. I only need one tail, and it's in the left side. We already determined that from the example that sample information that we're working with. I know that tail, the size of that tail is 0.01, which means the rest of it is going to be 0.99. And in my legend, degrees of freedom equal 14. Alpha level equals 0.01, one-tailed test, and t equals, do you remember the t-value we picked from the probability distribution? 14 degrees of freedom, one-tailed test at the 0.01 level, 2.624. I'm going to put that on my drawing too, but it's got to be negative. Why? Because it's on the left side. So t equals negative 2.624. And that's what that looks like. That's how we would set that problem up in terms of the drawing in order to test the hypothesis. Okay? Probability distribution, one tail on the left-hand side. Why the left-hand side? Because the information we were working with said lesser, all right? If the tail is 0.01, that means the rest of it has to be 0.99 because all of it together has to equal 1. 0.01 plus 0.99 equals 1. Degrees of freedom are 14. N sub 1 plus n sub 2 minus 2, or in this case, 8 plus 8 minus 2 is 14. You were asked to test this hypothetical hypothesis at the 0.01 level and a one-tailed. We consulted the t-probability distribution and found a t-value on the table of 2.624. However, because we're dealing with the left-hand side of the distribution, that t-value has to be negative. Okay, one more example, and then we'll get into some actual hypothesis testing.